Hopefully I do okay.
And like, you're talking about things like, you know, like how you like it. I don't think I know anyone who's gotten away. I got 20 that way for.
Like you literally did out in.
I'm not high, I know, I'm very much like, no, I'm 7 out of 10.
Did it under stable and then 2 now.
I got.
So now.
I want to show you now. I mean.
I think he's gonna.
It's really bad. Yeah. Honestly,
Yeah. Is yours on like? Yes, or is yours on like?
so.
Okay, guys, we're done with chapter 2, unit 2, but we still have these word problems to work through. We're gonna have a quiz over this sometime next week, but these are kind of word problems dealing with sine and cosine applications that we're going to involve with sine and cosine. So page 29 in your packet. All right, so problem number 1. An avid sky watcher, as an avid sky watcher, you know that the moon is always half illuminated by the sun, and that how much of the moon we can see illuminated depends on where it is in orbit around the Earth. For the first month of the year, you watched the moon and kept data for the amount of the moon that was visible each day. So the first row is a day of year. So we'll let that be T. T will represent basically our X axis will be our T variable. And then the proportion of the moon visible, we'll let that be the Y axis. Okay, it's going to seem a little tedious here. I'm going to start labeling them start 0 because we need to go all the way out to 60. But I'm just going to go by 2s. So. That should be enough to get us all the way up to 60. And we're going to see that when we graph these points and we graph this function, it should resemble either a sine or cosine. Okay, and then for the y-axis, we see the lowest y value is well 0, and the highest y value is close to 1. So I'm just going to go up by 2. Okay, so part A, so let's start graphing. Okay, this is so day 1, I'm going to plot 0.5. So you're just going to try your best to, yes.
What do I label the Y?
Oh, the Y is proportion of the moon visible here. And then T is the day and day of the year. Or we can say day of the month. Yeah, day of the year. So 60 days over the course of 60 days. So that means day 1, half of the moon is visible. Right. Day 4.81 is visible. 17. $59, not 60. So just as a reminder, your sine graph starts at the midline, rises up to the peak, back to midline, down to the minimum, and back to midline. Cosine starts at the peak, goes to the midline, minimum, midline, peak. So shapes like a cup. So looking at this graph, what does this resemble more like? Sine graph, right? Starts at the midline, peak, midline, minimum, and midline. So we can see that we see a full cycle completed here, and looks like by the time it gets up to 59 days, we have seen 2 cycles. Right? All right, so all right, if you guys can write this down here. Sinusoidal function, what does that mean? Sinusoidal function is a smooth curve with a repeating oscillating pattern around the midline. Comes from the word sine. Cosine is a sinusoidal function. Sine is a sinusoidal function because they both kind of have this this repeating wave shape that we come to know, right? Okay, thank you. Appreciate it. Okay, so everybody, have you, no, that's another few seconds here. So the period is going to be the length of one cycle. Okay, so it's going to be the end point minus initial point. So what day does the cycle end? Okay. Well, that's 2 cycles, right? Yeah. Where does the cycle? Well, yes, 30. Okay. When does the cycle begin? Day 1. So the period is just going to be your end point minus initial point. So what do you think the period is for this point? So I'm just gonna highlight one cycle, right? Because the sine graph starts at the midline, goes to the peak, midline, minimum midline. So it finishes its cycle on day 30. It begins the cycle on day 1. Okay, so 29 days. Now, where do you think the midline is for this sine graph? 0.5. Okay, so let's go ahead and you want to use a dotted line there. So vertical shift up 0.5, right? Good. All right, what's the amplitude? Good. Amplitude is the distance from the midline to the peak, right? Midline to the peak. We see midline is 0.5, the peak is 1. It's just a coincidence that they're the same number, right? But we're definitely defining them differently, right? D is the actual middle of the of our graph, and A is that distance from the middle to the peak. Amplitude. Okay, phase shift. So normally, the sine graph starts at the midline at 0, but this sine graph is a little bit shifted, right? It's shifted 1 unit to the what? Right, yeah, so it begins a cycle 1 unit from where we usually begin our sine graph. So phase shift, we can say there's a horizontal shift. One unit to the right. So we know our C value is going to be -1, right? Okay, part 3 says write the equation for the sinusoidal function. So if this is a sinusoidal, that means you can either represent it as sine or cosine. But given the choice, we're going to choose the easier one, right? It's closer to sine, so we'll just use the sine function. This is the form that we want to put them in. So we'll just do sine. I'm using t instead of x. So really, you just have to fill in the a, b, c, and d values, right? We have the a, we have the d, we have the c. We just have to figure out the b value. Okay, now what information do we have to help us get to the b value? Yeah, we have the period, right? Period is 29 days. So I'll spend some time working on that. What's our formula for period? The pi over b. Let's multiply. Okay, so fill everything in. We have everything available from that what we gathered. All right, next page. Any questions so far? All right, page 30, number 2. Okay, there are many rides at the amusement park whose movements can be modeled using trig functions. The Ferris wheel is a good example of periodic movement. And it's a periodic movement because the height of the ride is going to keep oscillating between lowest and highest point, right? It's just going to keep going back and forth in terms of if we're talking about this in terms of the height of the ride over the course of this Ferris wheel. Okay, so you want to ride the Ferris wheel. It has a radius of 95 feet. I'll go ahead and just label all the places that could be helpful with 95, right? We know that radius is just the distance from the center to the top of the circle, or a distance from the center to a point on the circle. Okay, just want to show that these are all 95 feet. Okay, and it's suspended 20 feet above the ground. So the bottom of the ride is 20 feet off the ground. The wheel rotates at a rate of 2 revolutions every 20 minutes. Now, 2 revolutions every 20 minutes, that means 1 revolution in what? 10 minutes. So 1 revolution. And in this case, what can we replace revolution with? Revolution is the same thing as what? Period, right? Cycle. 1 cycle is 10 minutes. So I can say my period for this problem, I can say is 10 minutes. So that kind of leads us into part A. What's the period of the function that models the movement of the Ferris wheel? And let's just go ahead and get this out of the way, right? If we know the period that models the movement of the Ferris wheel, we can also find the what? P-value, right? Eventually, we're going to write the equation, so let's just get that out of the way. Question so far? All right. Next part. what is the midline of the function? Okay, so I'm going to draw the midline, which is the center of my ride. So the question is, how far off the ground is that midline? We want to think of the ground as the x-axis here. Is it 95? $115. Okay, how'd you get 115?
I had 20.
All right, so if I imagine this as the x-axis, okay, right? We are the ride is going to be, the lowest point is going to be 20 feet off the ground. I got to add another 95 to get to the middle of my Ferris wheel. So 20 plus 95 is 115. So my D value is 115. So what is the practical meaning of the midline? Let's say midline is the average, or we can middle, but we can also call it the average height during the ride. Another way of saying the middle of the ride. Okay, what is the amplitude of the function? So if this is the midline, then the amplitude will just be what? 95, right? Midline to the peak, midline to the lowest point of the graph, lowest height of the ride. So my A is simply 95, right? Just the radius. Amplitude, this is the max and min height of the ride, either above or below the midline, right? I can go 95 feet above the midline or 95 feet below the midline, and those are the highest and lowest heights that I'll experience during the ride. Okay, so it says write the equation of the sinusoidal function that models your height above the ground over time. So I'm going to put this on a side sheet here so I don't have to keep flipping back and forth between the page. So think about it this way here. So our period is 10 minutes. Eventually, I want to graph it. So I need to find my interval. How do I find my interval? Period over 4. So 10 over 4 is 5 over 2, which is 2.5. So I think if we can kind of just gather these order pairs, that will make it easier for us to graph. So I want to create this table here. Let's say time t. And then y is my height. So let's think about it this way here. When we start the ride, okay, when we enter the ride, how high will it be off the ground? 20 feet, right? Because you're going to enter the ride here at the lowest point, and the lowest point is 20 feet off the ground. So you're going to begin the ride. So 2.5 right? A quarter of the way through the ride, we'll be here. Right, 2.5 minutes into the ride, we'll be here, and how high will be off the ground? 115, right? That's our D value. 5 minutes into the ride, which will be halfway. We know the full ride is 10 minutes, so halfway, assuming that this ride is going the same speed all the way through. Where will we be? How high off the ground? Oh, sorry, it's a 2.5. Yeah, so that's just my interval, right? So 0, 2.5, 5, 7.5, and 10. So 5 minutes in. Okay, so it got to be 20 plus 95 plus 95, which is 210. Okay. All right, 7.5 minutes into the ride, I'm back here. How high off the ground? 115 again. And then when my ride completes, 10 minutes in, positive 20. Right, positive 20. So let's use those order pairs, and we'll try our best just to sketch the graph to see what it looks like, and then we'll create an equation out of what we see. Okay. So I'm going to do my interval by 2.5 here. Zero, 2.5, 5, 7.5, 10. I want to eventually hit 220. You can do whatever you like, but I'm just going to go up by 20 here. There's just plot my order pairs that I found. I'm going to graph the equation first, and then I'll write the equation. I'll graph the function first, and then I'll graph the equation. Or write the equation. Okay, so starting at 0, 20. 2.5, I'm at 115. Five minutes in, I'm at 210. 7.5 got to 115. Then finishing off here. Okay. If you had to choose, which function does this look more like, cosine or sine? Cosine, except it's reflected, right? Because we know cosine starts at the peak, makes its way down to the lowest point, and then goes to the highest point. But this is more like an upside down cup, right? Which is just means that it's still the cosine function is not shifted, but it's just reflected. So I think knowing that, we know that we can adjust our equation with a negative in front to make it a reflection. So we're going to write the equation of this sinusoidal function.
Why'd you go back down at 7.5?
Why'd I go back down to 7.5? Because, well, if you think about this ride, right? This ride, we're starting at 20 feet. We're going up to 115. And then 5 minutes in, we're going to have the highest height, which is at 210. But then the ride's going to have to come back down. Right? And as it comes back down, the height is going to become lower, back down to 115 and back down to 20. So we're just, you know, as we're riding the ride, we're just tracking how high we are off the ground at any moment in time. All right, so this is the equation that we're going to try to follow. I'm going to use t being the variable here. We can use f of t being the height, or how about this? We can use h because it makes it look more like the height equation. Really anything. You can call it anything you want. Call it y if you like. I just want to create my formula in place. So we can fill in the A, B, C, and D values, and then we can write our equation. Okay, so. All right, what's our A value? Good. All right, so I'm going to draw the midline here if it helps. So numerically it's 95, but we said that it's not quite the parent cosine function, it's a reflected one. So I'm going to make that adjustment, make it a negative 95, since it's not starting at the peak, it's starting at the lowest point. Okay. We found our B value, right? What's our B value? 5. Okay. What's our C value? No shift, right? Because we're purposely choosing cosine so that it's easier. It's starting at the peak, right at 0. Sorry, starting at the lowest point, the minimum right at 0. So there's no shift. And then our D value is 115, right? Okay, so we have everything we need to build our equation, right? Okay, so now that we have our equation, we're going to use it to kind of help answer some of the questions below. Yes, question. You can use theta if you want, yeah. I just use T because it just feels more suitable for what we're using, but on the quiz or test, you can define your variable any way you want. All right, so part A, determine your height above the ground at 6 minutes. So how can this equation help us out? Yeah, plug in 6 for T. We've already built the equation, so now we can find all the heights for these points that are harder to do without a calculator. Right? So now that we have our equation, now we're dealing in terms of 2 pi. 2 pi is the parent graph, which means that our calculator needs to be in radian mode in order to adapt to that adjustment. So when you plug in P for 6, you want to make sure you're in radian mode, because we built our period and interval using 2 pi and 2 pi in terms of radian. So in your calculator, if you go to mode, you can kind of make sure and see if you can you can see if you can kind of find that radian. I don't know if you can see it here. Yeah, find that radian to get kind of toggle to that radian form, and then do second mode. I'll go back to your home screen. Okay, so now I can enter into your equation into your calculator. So practice entering that in. Let me know if you have any trouble in your calculator. You should get okay. So let me know if experiencing any trouble with your calculator, or if you're having any issues, I can help. Anybody have trouble, let me know.
It's supposed to be.
Yes, it should be Radian Mode. And
Rounded to.
it doesn't specify, I just rounded it to the nearest foot. But I will always, if I expect a certain decimal, I will detail it on the quiz or test. Okay, so I'll never expect you guys to know what decimal or what I'm looking for, unless I specify. So here, it doesn't specify, I just decide to go to nearest foot. Okay, part B. Suppose. Okay, part B. Suppose the Ferris wheel moved faster and complete a revolution in 5 minutes. How would the function change? So if I complete a full revolution in 5 minutes, what does that mean? My period is, instead of 10 minutes, is 5 minutes. Okay, so my period is 5 minutes. So that means it's going to produce a different b value. If I have a different b value, I just need to find that b value and I can update my equation. So instead of pi over 5, I'm going to make my b value 2 pi over 5. Just want to update my equation, reflect a Ferris wheel that is moving faster. That's moving twice as fast. Questions? Okay, part C, if the radius of the Ferris wheel remained the same, so let's say the radius is still 95. But let's say the height of the wheel was raised 15 feet higher. How would the function change? So basically, the Ferris wheel is moved up 15 feet higher. What would that affect? Or how would you affect your equation? Yeah, you just add 15 to the d value, right? Just if I shifted everything up 15 feet, then I'm able to fulfill this condition. So the midline would change, or change the midline. So I'm going back, I'm just using my original equation and I'm just adjusting that d value to a new one. So it's assuming that I'm still at the 10-minute revolution. Okay, let's start page 31. And so first thing, we're just going to graph the same way that we did before. Let the bottom row be months of the year. And then from 0 to 12. And then we'll let the y-axis be the temperature. And I went from 10 to 80. But you can always scale it differently. Sure, yep. That works. Yeah, you can scale it any way you want. Our graph, your graph may look a little more, vertical than mine, but it's fine. Yeah, scale it however way you want to. Yeah. So you don't have to do it my way. Guys, for our purposes, let's make that December go down to 40 just to make it a little cleaner here. Okay, so part A, what is the period of the function that models the monthly temperature in Atlanta? What's the period here? Yeah, I meant for this to be 12. So for January is from 0 to 1, and then February is from 1 to 2. Okay, so we'll say 12 minus 0, which is 12. Yeah, you're right. This should be, yeah, this should be, so that temperature is at the end of January. Okay, so yeah, it begins at 1, it ends at 12. Yeah, 12 minus 1 is 11. Okay, let's do that, 11.
Is it gonna be 61 or 62? Is it 53?
Midline is 60, yep, because it's halfway between the lowest and highest. So period is 11, which means we can go and find our B value. Our midline is at 60 because we see the lowest is 40, the highest is 80. So halfway between is going to be your midline. Okay, what's our amplitude? 20. Distance from the midline to the peak is 20. Okay, is there a phase shift? So it didn't start at 0, right? It starts at 1, so move to the right 1. So our C value is 1. And is this resemble more a cosine or sine? Cosine. Remember, okay, so this is not, it doesn't start at the midline, right? It starts at the valley, it starts at the minimum. So it looks more like the cosine, except what? That's the A is getting what? Reflected, so it's gonna be a negative A. So now if the graph started at the midline, peak, midline, if it starts at the midline, then we want to consider the sine. That'll be the easier one to do. But because it starts at either the peak or the valley, we want to target the cosine. Okay. And then for part F, so for E, we can fill in. Our A is negative 20. Our, sorry, I adjusted it, right? So 2 pi over 11 is our B value. Let me fill this in.
Or
Mhm.
B, it's saying to find K. Right.
Sorry, vertical shift, that should be the D value. Other formulas have K built in, but we're going to use D.
Is C -1 or?
It's going to be -1. Okay, we'll pick up tomorrow. Okay, don't forget your phones. We'll spend tomorrow and Friday just working through these sine, cosine word problems.
Wait, so Mr. Yan, because you're going to the right one, right? And the equation is -1, that's opposite. Oh, would it be -1 written or would it be 1? Directly.
You're right. It should be a positive one.
It should be positive 1. But in the equation, it's negative.
That's right.
All right.